For those of you who are sticking around for the last talk, thank you very much. It is my pleasure to introduce our final speaker of the session, John Yundt from SunRay Scientific. We'll be talking to us about flip chip die attach and flexible hybrid electronics.
Well, thanks everybody for coming. Really appreciate you sticking around. I know it's late in the day and everybody's waiting because the beer's probably already cold out there. But so today we've talked a lot in the past with our technology about different applications in wearable, attaching to fabric and textiles, doing all sorts of unique things with the Z-Axe material. Today we're going to talk about one of the more recent applications that we worked on with a development partner. This is a flip chip bare die attach for flexible hybrid electronics. In this case, really interesting set of targets. So they wanted to have a standardized process to make a bare die connection to a very fine pitch antenna being used for temperature logger applications. An RFID tag based system being used for temperature logging. They wanted to have improved yield over the existing technologies that they were using. They were looking for the ability to run at high throughput. So we're talking about a complete process that could manufacture up to 200 million tags annually. And they wanted consistent performance, both in antenna reach, induction, conductivity, and interconnect bond. So this is like I said, bare die attached for RFID on printed flexible substrates. So they also wanted to use a range of different types of substrates: thin film PET, paper, TPU. It was going to depend on what end application requirement for their customer was going to be driven. I can't divulge the end customer and the specific use other than to say temperature logger. You can imagine where that would get used. And the problem that they were having was it's a very fine pitch die. So basically 45 to 50 microns edge to edge that they had to attach to this printed flexible antenna. Thin film with low temperature substrate, 2 mil polyester can be tricky to bond materials to as well as to print on. So very low profile material. Existing approach was very costly and complex. It required scalability into high volume. So they had tried initially with an ECA material, and they had looked at ACF, couldn't do ACF because of the thinness of the die and the polyester film. The pressure was too much. And they even tried wire bonding. That was going to be very expensive, and it was a much slower process for them, so that wasn't going to scale well. And they couldn't get the bond strength of the component. And the ECA also failed because of pitch issues. They needed low resistance interconnection for the performance of this tag, and it had to remain very environmentally stable because of the harsh conditions it was going to be exposed to, which could include immersion in ice water. So the solution that we proposed, or they came to us and asked us about, was trying ZTACH ACE. I'll talk a little bit about the technology on another slide for those of you who aren't familiar with the material. But that is our anisotropic conductive epoxy. We can manage pitch down to 100 microns with standard formulations. That would mean 100 microns center to center, center pad to center pad. So that's a 50 micron edge to edge. We can go finer than that. We can go down to a pitch of about 60 microns, which would be 30 micron spacing, depending on the formulation we use and the density of the components being populated. And the goal was to be able to cure this at relatively low temperature. As I said in the previous slide, we can cure ZTACH in our standard formulation anywhere from 80 C all the way up to 160 C. So it works on a pretty wide range of materials. They wanted a reduction in cost and complexity, meaning the other solutions that they were going to have were probably going to either involve an underfill and encapsulation, or at least one or the other. They needed very high bond strength and durability to withstand the packaging and the processing, as well as just the transportation of the parts that these tags are going to be put on. It had to be designed for high volume and ideally designed for existing manufacturing processes. So a drop into existing SMT line process was ideal. And they wanted a contact resistance that was low, right? So our technology offers between 7 and 20 milliohm centimeter of contact resistance. That's pretty good. And this is for those not familiar with ZTACH ACE. We've been doing our presentations now at TechFlick for a while, so I think lots of folks know it, but for those who don't, fairly unique technology. So this is it's obviously an anisotropic material, so it doesn't require patterning. It's designed to handle fine pitch. We have patents on both the particle science here, which is a ferromagnetic particle that's encapsulated either in silver or gold. And then that's dispersed into the case of our thermally cured material, a 2-part polymer epoxy. We also have a UV cured version that's an acrylate-based system. And that material can be deposited basically in the footprint of the component. So